Epsilon delta proofs. They've been a topic that have confused young mathematicians and overall a lot of high school students. Well, what I want to do is kind of try to demystify it and make it make more sense. So let's think about this limit right here. What this represents is going to be this graph. 1, we're going up by 4 each time. We're approaching x equal 2, or in the general case, x equals c. And then we're going to have a point up here. In this case, it's going to be 9. However, generally, you're going to see it as L. What we want to prove is that within some kind of neighborhood is what we like to call in mathematics. A delta neighborhood of the function f, well, of x is a better way to put it right here. And then in this place, it's going to be the epsilon neighborhood. And so that's plus minus epsilon around L. But what am I saying? Why am I introducing these ideas? Well, the idea is if we add a nudge here, we should get a nudge bounded by plus and minus epsilon. So that is the entire goal of our limit proof, is to say that for pretty much every single epsilon you can give me, I can give you bounds within x that will make it so that our statement that we're about to come up with is always going to be true. So let's try to work on it. The formalization, how we're going to say that is, we're going to say that if 0 is less than x minus that point c is less than delta, then we want the implication to imply, or basically to force that the function of x minus point L is going to be less than epsilon. And so what we're going to be given is a choice on this delta. So let's work that out. In this function, what we're going to have is that 0 is less than x minus 2, which is less than delta. Okay, this is going to imply that our distance of this function, 4x plus 1 minus 9, is going to be less than epsilon. Now, what we want to do is kind of work backwards, because in proofs, a lot of time, that's just going to be what you have to do. So let's simplify this. We get 4x minus 8 is less than epsilon. Okay, I notice that we can factor 4 out. So we do that. This is not just convenient, this is what's going to happen every time except for every other time. But I'll show you the other case in a minute. We get this, which means that x minus 2 should be less than epsilon over 4. So let's suppose delta is equal to epsilon over 4. Okay, so this isn't going to be too far. We can work from here. So we work to this. Now what we're going to do is have this is then going to imply that 4x minus 2 is less than epsilon. We can bring it in, we get 4x minus 8 is less than epsilon, which then is going to give us our original statement. 4x plus 1 minus 9 is less than epsilon, which is proof complete as far as we're concerned. So there, we want to choose delta such that it is going to be the given epsilon over 4. And just to repeat the idea on what's going on, we're being given a range of y values that we're allowed to stay within. And we want to tell this person that's seemingly holding a gun to our head or something that, well, we're going to choose a delta within a range, and we're going to satisfy the condition that you've given us. This can be seen as allowed restrictions within, I believe a professor said to me, as the idea of restrictions within food, how much you can have of a certain thing before you go outside of limits that are allowed. So accuracy is going to be a better way of putting it. Epsilon delta proofs allow us to show an accuracy within bounds. So this was the easier case. it's going to get more unfortunate for us, however. But if you are in calculus, calculus 1, calculus 2, I don't know why you'd be doing it in calculus 2, but calc 1, calc 2, essentially calc AB or BC, I believe it's only a BC thing, I don't know if AB does it, then you're good. You're good where we have ended right here. If you are in an analysis class, however, this is going to be a more important thing, and I would not be surprised if your professor gives you a quiz on it, specifically on the example I'm about to work. And so, in that case, I do also want to recommend the book, Understanding Analysis. This book's great. It's by Stephen Abbott. I am taking directly from it for part of what I'm doing. So, a lot of credit goes to that. You didn't see that. The quadratic case. We want to show that x squared minus 1 is going to work out to be equal to, well, plug it in, we get 4 minus 1, we get 3. This isn't going to be fun. So what we have is we have 0 is less than x minus 2, which is less than delta, and then we're going to have 0 is going to be less than x squared minus 1 minus 3 minus 3 is less than epsilon. Okay, we notice that this comes out to be a minus 4. This now we're going to have to recognize is going to be a difference of squares. This difference of squares is going to give us x minus 2 plus 2 is less than epsilon. And I don't know why I put that there. My bad. That's supposed to be an implication. We're almost there though. We're going to have to use our heads to kind of do some analytical thinking. What do we have control of? Well, we have control of this one right here. This one we know is always going to be less than our delta. So what we want to choose is say what is reasonable for the biggest change that we're going to have. In Stephen Abbott's book, he says, okay, let's say delta is going to be less than 1 or less than or equal to. So what we're going to do is say, okay, suppose delta is equal to 1. So that's going to give us 3. That's going to give us 9 minus 8. 9 minus 1, which is going to be 8. Or, in this case, we plug it in, and yeah, we get 8. So, I know, it's a bit much, but we're just going to have to work through that. We know that 8 is going to be the biggest difference that we can get. And for this, it's going to be 2 plus that minus 2 is 1. So what we're going to do is we're going to cap x plus 2. And so what we're going to do is we're going to plug in, I'm sorry, this is real time. We're going to plug in that x plus our maximum delta, which is going to be 1, which is going to give us 3. 3 into this is going to give us 5. So ultimately, that is our max. That is the thing that we need to worry about. So we're going to choose that delta is going to be, my bad, equal to epsilon over 5. It's not a fun argument to make. You're going to have to be able to word it nicely. And I'm just going to say it again because I felt like it wasn't particularly amazing when I said it the first time. We recognize we have control of this because it is bounded by our delta. However, we have this statement. This statement can grow a lot. So we say our reasonable delta neighborhood is going to be within 1. So plus minus 1, that's okay. We add 1 to our value, which is going to be 2 plus 1, which is going to be 3. We put that in here. Now we know that our greatest growth from this exclusively is going to be 5 within our reasonable bounds. We get 5 times that. We divide it out, like earlier, when we pull that factor out from the linear. That is going to let us then get epsilon over 5, we say, okay, delta is going to be equal to that. Then you can go, you can check it, and it will work. To anyone working on analysis, please, if you have any specific questions, ask them. I'm happy to answer. This book, though, is going to be your best friend. Calc students, any questions as well, please ask. Good luck. We're reaching the end of the semester. You're going to do fine on your AP exams. Don't stress it. Good luck, everyone.